Shannon Babb. I'm an interdisciplinary earth scientist. My background is in geology, hydrology, soils, and then I went back and got a master's degree in education. And I also have the advantage of my younger brother actually has worked on several NASA projects. He designed satellites, and we have spent many an evening arguing on which planets we should visit and why different types of science fiction are realistic to an engineer versus someone with a science background. So that's kind of my background that I'm bringing to this panel.
I don't know why they put me on this panel. I'm a photojournalist and author with an interest in science, and I was taken aboard a craft when I was 7, so I know they're real. That's about all I can say.
What do you do yourself? What are your...
I'm freelance now. I used to work for the International Herald Tribune in Paris and the San Francisco Examiner, which doesn't even exist anymore, and a few others. And I write nonfiction.
So, as we were starting to get in, and people were coming in, we got a little bit of feedback on some of the things that people were interested in, such as around life. Should we even should we even travel to Venus and try to set up a community? Which I think is probably a good place to start. Should we try to create a colony on Venus? It's going to be expensive. It's going to be hard. Should we try? What do you think?
The sulfuric acid alone would kind of keep me at bay. The good things about it are Venus is similar in size to Earth. It's only like, what, 5% difference? But you look at the thing, and the day is longer than the year. It takes longer to rotate around itself than it does to go around the sun. And that's just bizarre. And we can't even clean up our own inversion here. How are we going to suck up all this stuff there to make it habitable? Although, you know, we can put in little spheres of...
That brings up a good point. Who thinks that we should live on the surface of Venus?
Just like...
Well, in 10,000 years, maybe, if we're terraformed.
Who thinks that maybe we should create floating cities? I vote the floating cities. Yes, sulfuric acid is an issue. Has anyone in here worked with sulfuric acid? I work with it on a regular basis. Even now, I used to work with it multiple times a day. It's a scary acid. But how do you contain it? Not really, no. Plastic doesn't react. You can use carbon fiber and it won't react. There's a lot of things. You're only dealing with an issue with sulfuric acid if you are trying to put metal directly in it. Well, we tend to build spacecraft partially out of metal, but we build spacecraft out of a whole lot of other things that aren't going to react. So it becomes a whole lot more realistic to build something on Venus if we stop getting out of well, it has to be a metal spacecraft. We could do a carbon fiber 3D printed floating city, and that becomes a whole lot more probable because what does Venus have in abundance in its atmosphere? More than any other element. Carbon dioxide. We already have carbon there, and what do we need when we go? What do humans need to bring with us in order to survive in space? Oxygen. So we have the ability. Do we have the technology to economically split that? We have plants. not particularly efficient. But when we look back in time at Earth's atmospheric composition and Venus's atmospheric composition were a lot more similar than it is today. In fact, the first organisms that lived on Earth that created oxygen kept on killing themselves off, because it turns out that for early life on Earth, oxygen was a toxic byproduct of their metabolism. So we can start developing and start looking at what our communities on Venus might look like, because, okay, we've got plants. Are there plants that can deal with sulfuric acid now?
Yeah.
Yes, they exist here on Earth now. Anytime you go to a volcano and you're looking at some of those extremophiles, they love heat. They actually utilize sulfuric acid as part of their metabolism. They need the sulfuric acid to survive. So, and they will also access photosynthesis. Part of their internal chemical reactions use sulfuric acid. And if you want to visit some, you can actually see them. Go up to Yellowstone. Those rings, each color of the rings is a different type of organism that you can go and look at and see what their temperature preferences are. If you see the really clear blue water, don't touch that. That's too hot for the extremophiles to survive, so you probably don't want to poke that water, as your finger will get cooked almost instantly. So we now know that we've got some resources. We could build a floating city if we wanted to, but we are going to have to not engineer it like a human would here on Earth, because we're going to have to use different resources. So our next step is, how are we going to travel?
Stargate.
Stargates would be awesome.
Venus is a lot closer to Mars, isn't it? What would be wrong with just a regular rocket? I mean, assuming it's not made out of metal, as you said.
Well, as long as it doesn't enter the atmosphere, we can travel there and just have the vehicle that enters the atmosphere.
So how are you going to make the floating city float?
Just a moment.
Doesn't that have to do with atmosphere density?
Yeah.
Yep. You are going to bring different types of gases. Now it turns out oxygen will float in CO2. If you create gigantic balloons where you're putting in your oxygen as you're producing it, you don't need helium. You don't need any of the gases that are lighter than air here. There's so much CO2 in Venus's atmosphere, you could create a floating city by having a large volume of oxygen.
So how, far above the planet would you float? How cold would it be? What would the effects of gravity be on you when you're at such a height?
So we're going to probably deal with a little bit lower gravity than, we definitely would have some lower gravity than you would at the surface of Venus. That's okay. We'll still have more gravity than Mars. As far as exactly where you're going to end up, that's a density calculation. Hand that to an engineer. It will make them happy. They'll calculate based on the size of your gas sphere, the density of your gas sphere, how much gas you're pumping in, because you're probably going to have that change over time, depending on whether you're on the day or the night side of the planet will affect where you're going to hit. If you ever look at dirigibles, which basically it would be a dirigible city. Instead of helium, you would be using oxygen, but it's the same concept.
What would be the point though if you just float above it and you never get to see the surface of the planet?
You don't want to see the surface of the planet at least for a while. When
Yeah, that just goes.
Venus gets hot enough, and we're pretty sure that Venus does not have a liquid mantle, does not have volcanic activity, but is relatively free of craters. And so what geologists, planetary geologists have pretty much figured out, the only thing that could have caused that is the atmosphere actually heats up the planet so much that on a regular interval, it gets so hot, all of the heat in the rocks have built up until the point where the entire planet melts and then resolidifies. Yeah, not going to be the best place to move. If we do want to move there, there is a really crazy fun plan
To terraform it.
to terraform it and Mars at the same time. Because what does Venus have too much of?
Atmosphere.
Atmosphere. What does Mars have too little of?
But doesn't like a big part of the reason Mars doesn't have an atmosphere is its lack of a molten core creating a magnetosphere? And so the solar winds just kind of blew it away? Like, does Venus have a magnetosphere?
So, Venus, I'll have to look that up. I do not know that off the top of my head because we haven't discussed that in our arguments yet with my brother. But with Mars, one of the other reasons it lost its atmosphere is its gravity. It's too small to hold as thick of an atmosphere as it's had historically. So you could not balance that out.
Google says that Venus probably has a molten core, but spinning so slowly it has no magnetic field.
So why haven't the winds blown up the atmosphere? I'm sorry.
It has that much atmosphere. Yeah.
So it's just like winds and atmosphere coming off of it every day?
We're losing parts of the atmosphere on Earth. Our gravity is actually not strong enough to hold helium, and we lose that to space. So every time you let go of a helium balloon and that helium bursts out, we lose that to the universe. We're not getting that back. It doesn't go into the atmosphere, it goes out.
Well, there was a big shortage of helium not too long ago. So naturally occurring helium is in short supply now.
Naturally occurring helium occurs because of nuclear reactions. And so you find it with deposits with radioactive substances. And so it's a finite supply. Venus's atmosphere is mostly fairly dense materials. It's got some nitrogen in it, it's mostly CO2. Has anyone heard of the exploding lakes of Cameroon?
Yeah.
So I'm getting some yeses, I'm getting some really confused looks.
Sounds really familiar.
Explain.
So you can have volcanoes that will put lots of CO2 in the bottom of a lake. And it stores up and it stores up and it's pretty much pure CO2. And eventually you have so much gas that it will come out of solution. It's like shaking a bottle of soda. Comes out of solution, releases that gas. The CO2 is so dense and it's 100% CO2, it will roll over and cover the ground. And it will actually suffocate people because it's a thick enough layer of pure CO2, it displaces all of the oxygen. And if you can get up on the hill, you'll live. But if you can't get to a hill, entire villages got wiped out. So that's what you're dealing with. You're not going to want to walk outside of Venus because of because of the sulfuric acid, but you're going to be able to float and create something that's buoyant in an atmosphere that we can breathe because it has so much CO2 outside.
Kind of sounds like we should just send weather balloons to Venus.
Said what?
We should send weather balloons
There we go.
rather than surface probes.
That's actually the new plans.
Oh,
That is what ESA is looking at. That's what JAXA, the Japanese Space Agency, has been looking at. That is what NASA has been looking at. And there's a reason why many of these space agencies are starting to accelerate looking at Venus, because before, Venus was kind of boring. When we finally figured out that the bottom of the ground of Venus is like the worst possible place to try to land something, we kind of turned our eyes towards Mars because, well, maybe we could go there. But in the last 2 years, they're starting to discover some signs that there might be life on Venus. Well, we don't know if it's microbial. It could be more complex. Here's what they've been doing. They've been sending some probes and scanning and looking at the atmosphere, and they're discovering that there are layers in the atmosphere that are absorbing UV radiation. And there's not chemistry going on in the atmosphere that they can figure out that can explain that. But it turns out there are some things that are really good at absorbing UV radiation. Plants. That's actually how we've mapped plant life here on Earth, is looking at the types of radiation that they're absorbing. So there are current hypotheses that we might have life on Venus. Now, we're going to have to actually travel there. It's going to take scientists and science fiction people to start thinking of how are we going to do that.
So, we love thinking, I was just at the evolution one, we love thinking about ourselves as we love just exploring for the sake of exploring, but unless there's self-interest, there's actually no reason to go to a place. Even the explorers in America, they didn't explore because they wanted to explore, they explored because people gave them money, and, they found gold deposits or whatever the reason was. Why would we go to Venus? What's natural? What's a motivation to get humans to go to Venus, other than maybe stripping of this atmosphere from Mars or something esoteric? Is there a gold, titanium? Is there a reason to get humans there?
There's always benefit to science whenever we extend ourselves to do anything like that. So I'm sure to the scientific community, absolutely, why wouldn't you? But, I look at like C-Lab, for example. Of course, it went underground. It's an unacknowledged thing now, but it's still going on. But it was pretty much unsuccessful. Then if we can't even survive under sea, how are we going to survive on Venus?
I would argue because we don't have money coming from space.
This is true.
And again, I'm with you, but I did just go to this evolution class. Now I'm super jaded and all humans are awful, so.
We are locusts, you know.
Exactly. So I'm trying to think, is there a way to motivate us other than, again, I'm on board. I love science for the sake of science and learning for the sake of learning. How do we get capitalists?
Big money.
Big money. Yeah, Jeff Bezos, who is, pretends he's helpful, but actually just wants more money. How do we get him involved in going to this?
What is a great fuel if you need to go interstellar? You're going to need fuel. Turns out carbon burns pretty darn well. If you need a whole lot of oxygen for a interstellar voyage, you now have a source of lots of carbon and lots of oxygen. Now, if you've got the technology to do that, I vote we do that with like planet Earth first. We've got enough carbon imbalances going on. But if we've mastered that technology here on Earth, and we try to tap too much CO2 from the Earth's atmosphere, someplace like Venus is almost an unlimited supply, at least on human timescales.
Here's another question, right? You see guys use like AT3 or something like that for a fuel in their science fiction. What was that versus CO2? Or are they just science fiction guys also analyze dragons?
I will admit, I don't know.
Are you talking about helium-3?
Yeah.
Okay.
That's AT3 or AT3, sorry.
Well, it's a real thing and it's viable and it's all
It's
over
just-
the moon, but how do you get it? That's the problem.
It's not readily harvestable. Yeah, CO2 would, using carbon dioxide would be heavier. But if it's cheap and easy enough to extract, you just build a bigger spaceship.
Yeah.
Do we know, so Venus has, we know, CO2 and the acids, I forgot, sulfuric acid. Do we know of any other things that it has that we'd be interested in, more along the lines of harvesting? If you have that memorized.
We know that the atmosphere is primarily CO2, nitrogen, although
We have that here.
we have that here, and it has much less nitrogen here than it has on Venus. It's a much smaller percentage. One of the things it has in abundance is lightning. And there's some really interesting chemistry that happens when you have that much natural power. We can actually, if Venus gets a good enough lightning storm and you have a powerful enough telescope here on Earth, you can actually see the flashes
That's right.
in its atmosphere. So that's a lot of electrical power that you might be able to tap for something. As far as the surface, we've got a lot of hypotheses. We have not had a probe last long enough on the surface to take a sample.
An hour. We were there an hour.
Not long enough to take a sample. Take some photos.
They didn't make it out of plastic, this probe.
Well, but it's really, really hot. Like
Yeah.
hotter than a blast furnace at the surface.
Yeah, so, at the surface.
Even on the dark side.
Yes. Greenhouse effect.
Okay. So even though only one side is being lit, the other side is still very hot. Interesting.
I was just curious about, do we have satellites around Venus, or is all the observation from satellites here on Earth?
I cannot remember. They had a recent mission that did mapping of Venus. They used cloud penetrating radar. And that's how we actually know about the lack of craters on Venus, is they sent a specialized space probe to map it.
There are no satellites.
But no permanent satellites?
No permanent
Okay.
satellites.
No good economic reason.
No. Well, it's not just the economics of what it can bring back, but it's the cost of putting.
If there was a device that could withstand the temperature on the surface, how would we harvest the lightning?
Well, most lightning, even here on Earth, never strikes the ground. Most lightning distributes electrical charge from one cloud to another. So it might be easiest to collect lightning
How would you
actually in the
We
cloud.
need to figure out how to collect lightning here on Earth, though.
Yeah, that might be a good start, don't you think?
How would the dirigibles fare in the lightning?
Yeah.
Well, I've actually been in planes that have been struck by lightning multiple times.
Metal box.
As long as you're not attached to the ground in any way the lightning goes straight through.
Yeah.
Where does it go to, though?
So I know.
So it hits, does it go into the next cloud or just kind of keeps going?
Yeah, it kind of goes into
Yeah.
I can actually answer for the dirigible one because I was researching that like just literally 2 days ago on another book I was writing. Dirigibles like the Heidenberg, even the Heidenberg had anti-lightning measures. Like they're set up with like specific engineering, and so like the most they have is like lightning would hit it, just kind of pass through it, and they'd maybe get some black marks here and there, but they never had it ignite. It would never ignite any hydrogen or anything like that. Like so, they never had any issues with it. Like they did do like their whole research papers on how it would, what the areas that were most likely to start worrying where they would want thicker fabric for their balloons, but that was it.
Interesting. Yeah, it was interesting. I think we really do need to do a little bit more experimentation on Earth to see what can be done there. And I think this Salt Lake Valley would be a good place to start. Figure out how to get rid of inversions.
One of the first things you said, and I actually had it written down, was that we can't clean up our own inversions, and I'm again very jaded right now, and I apologize for that. But can't or won't?
Won't.
Yeah.
Exactly.
Geologists will argue with you.
Really?
Inversions is physics. Now, the pollution in the inversions is something else.
Yeah.
And we can work with finding solutions to that, but we know that inversions happened here and had major air quality issues because of wildfires and all of that, because we have a valley. We have a series of valleys. And this happens anywhere in the world where you have a series of valleys. You get cold air that gets trapped, and you get hot air on top. Basically created a lid. And that physics, as much as humans would like to change the laws of physics, probably isn't going to happen anytime soon.
If you do speak, I had a third grader do that. We could just have this big fan. But biologically, I remember in 1978, there were biologists who had created something that would actually eat the what do you call it? It starts with a P. Particulates. They made it so that was its food source, and they could go and eat the particulates, and it would go away. But the reason they didn't continue with the experimentation on it is because they said, well, then what happens when it eats all the particulates? Then what's it going to start eating? And we don't know, and there's no way we can test for that, and therefore we won't do it. Well, it just didn't make sense to me, because I thought if the food source goes, maybe it dies too, and that's fine, because we don't have the inversion to deal with
eating stuff that isn't so particulate.
That sounds like the start of a lot of science horror novels. Hey, you, oh no! How could we have not seen this?
I happen to be a science optimist, and I know that we're already using bacteria like that to deal with some of our heavy metal issues, to deal with groundwater contamination. There's a lot of places where that's already taking place. Problem is, the atmosphere is kind of a tragedy of the commons situation. Basically, everyone ends up adding a little bit to it, and it makes it very hard for everyone to make that change to benefit. When one person is the source of the problem, they have a whole lot more economic incentive to fix it, because otherwise governments and other people sue them.
Why is that
always about money, isn't it?
Agreed.
It's hard to overcome millions of years of evolution that incentivize that.
Well, back to Venus.
Sorry.
So they have lightning storms. I have not studied anything about Venus, so tell me. Lightning storms, I assume it has weather patterns. How dangerous would those weather patterns be to your floating cities?
They make hurricanes look wimpy.
Yeah.
So I don't know how you would survive.
You
other
are
than
going
just
to be
whipped around.
poking it through through the atmosphere in your dirigibles. So, luckily, unlike on Earth, you're not going to run into any mountains or anything like that. Your main concern is going to be making sure you don't run into another dirigible city as you're booking it around the planet Venus.
Kind of swirling around constantly.
In many ways, that's going to give you more of a day going around in one of those bands versus basing your day on
Venus.
On Venus's rotation. It's your day is how many times you get swung around Venus.
You had another.
Well, that was actually going to be my question, is can you alleviate the day-night cycle issue with that?
That's
Well, you can make it whatever you want to be. I mean, it's like guys on suns, they never see the sun, they have no idea.
Or even just polar extremes. I mean, the sun goes up for 3 months and the sun goes down for 3 months, at extreme times of the year. So it's not as if it's entirely unprecedented on Earth.
Well, couldn't you also just automate this thing? You don't need to have people on it.
Yeah, we might not be able to have people on it.
I wouldn't volunteer. I'll tell you that right now.
Are there places where the weather pattern would be less extreme? I mean, you're not limited by orbit if you're floating, so if you were floating over the poles, would it be less extreme, or do they know that much?
What you're going to be looking for is something called laminar flow. So laminar flow is, you may have very high speeds, but you aren't going to have the turbulence.
Okay.
So you love when your plane gets put in the jet stream and you got really good laminar flow, you're booking it. You use a lot less energy and you don't have those turbulence that make you seasick. The poles, you're going to see more of that seasick. Equator you get more. It's actually you get bands in the temperate zone, and that's, again, where here on Earth you get the jet streams. The jet streams are examples of those laminar flows. You catch those, and you put your floating city on that.
And then it will hopefully just keep going around.
Those are one big loop.
Yeah.
They do not end. In fact, if they do end up breaking, that does really bad things to your climate and everything else.
Cool. Just kind of random question. So it kind of sounds like one of the best, most lucrative things you could get out of Venus would be the carbon and the carbon dioxide for fuel purposes, for early fuel. Is that correct?
Right now.
Or if we make it so we can't grow food here.
Plants love CO2. Can you imagine the types of farms you could do with electricity from lightning and an endless supply of CO2?
Well, that'd be constantly in the sun too, it says that.
This is kind of a random question, but just all the talk about the atmosphere and how thick it is and everything, I'm just kind of wondering, would it be fair to say that Venus is a rocky planet disguised as a gaseous planet?
Oh, for years we thought it was gaseous, though. Yeah.
There's a lot of similarities. The big difference between the gaseous and the rocky is radiation. Gas planets are failed stars, and many of them are really radioactive. It's one of the reasons why, as much as I would love for us to create a settlement in like Io and Europa and those places, it's not going to happen until we get a whole lot better managing radiation, because your radiation doses would kill you within the day. Venus, on the other hand, you have some of the same properties of a gas giant with that massive atmosphere, but you don't have the radiation doses. In fact, the atmosphere helps shield you from radiation.
Okay, so sorry to move away from Venus, but radiation is still heat, like, so, like, if we were to try to colonize, like, one of the moons of Jupiter, like, I've always assumed it would be incredibly cold because it's so far from the sun. If Jupiter's sending out that much radiation, would it not be as cold as I was assuming?
The reason why Io has volcanoes is because it's getting enough heat from Jupiter, and it's also being pulled so much because of gravity that it's producing internal heat. As far as we can tell, Io may not be the only moon of Jupiter that has volcanic tendencies. They think Europa might also have volcanoes. We know that Titan, which Saturn's Titan, has a form of volcanic activity. It's not just Earth.
What are you guys writing right now about Venus that you need information on that she might be able to help you with?
I'm looking at chemistry and chemical components because I don't, one of the biggest oversights of humanity is that we think every other species is going to be using chemical rockets the same way we do.
Right.
That we're going to dig up dinosaur bones and that's what we're going to treat as our main source of energy. And I don't think that that's accurate. It's what we did, so it's our favorite, and we hold that near and dear. But solar energy, even just chemical packets, so on and so forth, just seems more readily available to me than digging up big holes in the ground and pulling out swaths of black stuff. And so that's one of the reasons that I was interested in this one. Is I'm curious about chemical reactions that we can create. Can we seed the clouds that we have there with something that would actually start the rampant greenhouse gas problems that they're having. Basically just playing with chemical compositions and what other species could possibly use, intelligent species might use, that we just wouldn't even know to look for because we're egotistical.
When you talk about chemical processes, the thing that I immediately started thinking about is lightning. Because you get all sorts of really funky amino acids and other stuff that form because of lightning. It's not the best source of fuel, but that might be an interesting thing to delve into as far as, are you going to find a completely novel medication because of how the carbon gets organized by lightning? Are you going to find a new type of plastic? What types of things will spontaneously be created by lightning? Because we know that happens here on Earth. In our atmosphere, what's going to happen in a different atmosphere? So we have enough time for one or two more questions.
Given the laminar flow and all of the dirigibles hurling past each other, how would we be able to go from one dirigible to another?
Good question. That is you know what? That may be a major issue that your characters are going to have to solve.
I have friends working on that right now, but I can't talk about it.
I actually have a slight issue for that. If you're both in the same stream, then you're actually moving about the same pace. You're actually basically still in comparison to each other. So it's actually, having a jet from one to the other is actually pretty simple, because you're effectively not moving. If you're it only matters if you're moving at different speeds, and then it becomes a little bit harder how much power you have to get from point A to point B.
Boy, I would think though I'd want those puppies as far apart as possible. You know, just saying.
Like maybe you could just launch off out of the airstream, like into the atmosphere and come back down. Where the other one's going to be.
That's another one.
We also have really good artificial intelligences that are already modified with what birds do when they fly. Birds don't run into each other when they do those insanely movements.
Yeah, I've never seen a bird hit another bird.
No.
Or a bat. And have you ever seen a bat cloud? Holy cow. How do they manage that? Even wingtip to wingtip, they just never hit each other.
Well, thank you so much for coming and adapting with us on this panel. We were short a couple of people, but we hope that you took something that's going to help influence your writing. So thank you.